Hello, welcome to JNUC, and thanks for watching our session, Passwordless Authentication with Jamf Connect. Before we get into it, right up front, I want to pause and allow everyone the opportunity to read through our forward-looking statement disclaimer.
We'll wait while you digest this, or since this is recorded, you'll able to push pause and then read it at your leisure.
Wonderful. All right. So I'm Mike Vandelander. I'm the technical product manager for Jamf Connect here at Jamf. And today I'm joined by Joel Reddick, our director for Jamf Connect.
Hello, welcome. Always excited to talk about some of the new things that we've been working on and some of the technology that we've got coming up. So very excited to show this off with Mike. And yeah.
Right into it then. So again, this is Passwordless Authentication with Jamf Connect. And for today's session, we have a number of segments that we're going to be talking through. I'm going to give everyone a quick overview of the wireless technologies and other technologies used to support our passwordless workflows. We're going to walk through a quick demo of using passwordless on the Mac. We'll talk through how passwordless workflows interact with other products. And then we'll finally discuss quickly how to deploy these passwordless workflows within your environment. So I think the first question to get out of the way is, what about this workflow actually makes it passwordless? And we need to keep in mind that these workflows are all being presented in the context of Jamf Connect. So if you're not familiar or haven't used it already, Jamf Connect is our application that allows for an integration between an organization's cloud identity provider and the user accounts on the managed Macs within the organization. So traditionally speaking, Connect supports workflows to sync passwords and help provision local user accounts on Macs with an approved username and all the privileges to match those accounts as they're set in the organization's identity provider. So this means that an individual can set up and use the same username and password for the local account on their Mac as they use for all the other single sign-on services. So we want it to be as easy as possible for users to get set up and be productive on their Mac. But we also know that managing passwords can be one of the most frustrating and time-consuming issues that our users will come across. So what if we could remove any requirements for entering a password and logging into your Mac became as easy as unlocking your iPhone?
It would be amazing.
So what we've set out to create is an app for the iPhone where a user authenticates to their organization's cloud identity provider, and by simply unlocking the app on the phone, their secured credentials are used to log into their local account on a nearby Mac. And Jamf Connect is able to achieve this because to the Mac, Connect is actually behaving like a smart card. So, smart cards, for the uninitiated, are physical cards or security keys that can be used for a number of authentication purposes, including access to a computer or a network. Similarly, a contactless smart card usually needs to be held close, physically close to a smart card reader for data to be transmitted. On the device that users are authenticating to, they would typically then need to enter a PIN as an extra layer of security, and then they're authorized to access that device or application or service. In our situation, Connect is acting the same way as a smart card by providing the user an ability to leverage their cloud identity that then requests an identity certificate to be added to their iPhone. And that certificate's then protected by the secure enclave on the phone. When the Connect app on the iPhone is paired with the user's Mac, that identity certificate is validated by the Mac. And it's then used to log the user into their local account. With the phone and the Mac paired, whenever the individual needs to access their Mac, they can simply unlock the Jamf Connect app on their phone via Touch ID, Face ID, passcode, whatever biometrics they have available to them. At that point, the Mac is wirelessly communicating with the phone as if a smart card had been inserted. At that point, a user could simply click to log in to their account or enter a PIN in the case that that's being required. So you don't need any extra hardware. You don't need any cards, security keys. You can just use your iPhone and your Mac to sign into your accounts. So to review, the user has an iPhone. They have the Connect app on their phone that allows them to sign into their cloud identity provider in order to load an identity certificate onto the phone. The Mac, meanwhile, allows a local login using that certificate for authentication credentials if the certificate can be validated. So on an ongoing basis, whenever the user needs to log into their Mac, they can use the biometrics on their phone to unlock the app, which in turn allows the user to unlock their Mac. If having a backup option is a concern for getting into your account, users can have multiple devices associated with their account. But also remember that going passwordless is meant to be a convenience for the user without having to compromise on security. So this process doesn't prevent anyone from having a password associated with their account if they want it. Additionally, if, say, the battery on their phone is dead, you could still sign in by knowing the password for your identity provider in the case that Jamf Connect is there synchronizing those passwords.
So now we can get into a little bit of a passwordless tech overview as we dive in. And it's important to keep in mind, you know, when Mike went over was kind of the higher level, we're going to go a little bit deeper here in this next section. And you may think this is incredibly complicated. And to some degree, that's not wrong. However, we think we've done it in a very elegant way for the user that they don't know or don't realize all these things are being done under the covers. And so that's part of why we wanted to kind of dive even deeper into this. So as an administrator, as somebody who might be managing a number of these devices, you have a good understanding of what's going on. But if we've done our job here at Jamf, most of this will be completely transparent to the user. So dive a little deeper here, but then show you it live in action. And I think you'll believe and agree that it actually is quite user-friendly as we go through this. Three kind of major technologies and Apple APIs specifically that are being used for this. Starting on the left, you've got smart cards. We're using Crypto Token Kit. For those of you that are in the government space or care about regulations, we don't bring any of our own crypto. So we're using all of the Apple API cryptos, Crypto Token Kit, Crypto Kit, some of the other ones that are out there, Common Crypto. So everything's covered under the FIPS 140 validation that Apple has done. None of the crypto or anything else is our own. So that's important to understand. So that's on the left. We'll get into what Crypto Token Kit is doing for us in a little bit. In the middle, we are now using, this is a little newer than what we showed off last year. We're now using Apple's multi-peer connectivity frameworks. Whereas previously we were relying just on Bluetooth. Bluetooth is kind of the lowest common denominator that you're going to have for communication between your Mac and your phone. Bluetooth, as you're probably aware of, has its little own idiosyncrasies. And so Apple has an API called Multipair Connectivity. What's used behind AirDrop, for example, Bonjour is included in that. So now we're using that for the primary communication method. And then falling back to Bluetooth if we need to, and then using Bluetooth for a little bit of the beaconing. So we'll talk about that in just a second here. So again, the three major APIs, Crypto Token Kit, Multi-Peer Connectivity, and then core Bluetooth. So if you're a developer and following along at home, this should give you a good understanding of the stack that we're using. With Crypto Token Kit on the Mac, our app becomes a Crypto Token Kit driver. So we act as a driver that's able to see cards. However, unlike the drivers that you're probably used to, which act upon USB insertion and removal events, we're actually doing that through software so that we can trigger an insertion and a removal on our own. So nothing needs to be connected, nothing needs to be plugged in, no USB drivers are set up or anything along those lines. With Crypto Token Kit, it allows you to do signing, decryption, and if you're using elliptical curve keys, you can do Diffie-Hellman and key exchange. We can handle all of those through our driver. For the most part, we believe folks will be starting with RSA keys being pulled down from a Microsoft NDES server, as that's a SCEP process that we're currently supporting. So all of that can be done just like you could do now with potentially if you have a YubiKey, for example. I always keep a couple around here so I can show them off. So if you've got a YubiKey and you're using that as a smart card, we're doing something very similar. We just happen to be using the phone for that action instead. Although this is working as a smart card, our initial intent is not to replace smart cards. We are looking at making sure that we can handle multiple certificates and things like that. So if you do currently have something that's covered under FIPS 201, we'd love to be able to talk to you about supporting that. But right now we're mostly focused on just let's remove the requirement for a password on a user, give them a more secure and a more functional way of signing into their Mac. So since we've covered on a couple of things here, there's a brief PKI interlude. We could be here all day if we get too deep into some of the technologies and the other things that are being used.
Is this the more complicated part?
This is the absolutely more complicated part. Yes, indeed. So we're not going to dive too deep, and we're going to gloss over some of the actual PKI. Just keep in mind, like I said earlier, we're not bringing any of our own crypto. We're very smart people here at Jamf, but we're not that smart. So we're using the crypto that comes with it. And again, we're operating very similarly to how a smart card does today, with signing operations are being done for the authentication of the Mac. And all of that's built into the Mac currently. So again, if you're using a YubiKey or some other things, we're doing pretty much the exact same process. We just happen to be doing it over a different connection method to the phone instead of to some sort of, token or piece of hardware, something like that. So hit PKI, told you what it is. We do signing. We can do decryption, much like you could with this card. We won't talk about that today, as that's something that we'll get into later on as we get this app a little bit closer. All right, multi-pair connectivity. So this is what's behind AirDrop and Bonjour. And it allows you to make either infrastructure or ad hoc wireless connections. So this allows the Mac and the iPhone to connect over wireless. Neither one has to be actually associated with a network. They could just connect. There's something in the wireless chipset. People more aware of wireless than I am will be able to explain this to you. But they create an actual ad hoc peer-to-peer network. It doesn't knock you off the infrastructure wireless. In fact, you don't even know it's going on. If you've ever used AirDrop on the Mac, from your iPhone to your Mac, works pretty well, a little less finicky than Bluetooth. You don't have to do the pairing and all these other things. And so we're then going to be using the exact same functionality. Both multi-pair connectivity and Bluetooth have their own encryption layer on them. We are adding our own encryption layer on top of that, which we'll explain in a little bit. So we do expect, a belt and suspenders kind of operation here, that we won't necessarily trust or expect the underlying communication protocol to have encryption, because we're going to have a much better way of doing it on top. If you do end up getting doubly encrypted, well, hurrah, that's exactly what we're hoping for. That you would be, even safer with this. No configuration is required for this connection to work, because it's kind of built into the OS. One of the limitations of this is it is only Apple technology. But you probably won't be surprised if you've ever read the Jamf mission statement that we're not incredibly concerned with enabling non-Apple devices. So we're okay with this. And again, you've probably already used this technology but didn't really realize it. As multi-pair connectivity, AirDrop on the left there, and then Bonjour, which is kind of included as how its discovery is done and things like that, is part of this framework that we're using. So again, technologies that are already there that you already may be doing, we're continuing to use. We also do use a little bit of core Bluetooth. And this is specifically for a beaconing, right? If your phone is off or in your pocket, the Mac will turn into a Bluetooth beacon very briefly. That will wake up your phone, because we'll be listening for that. And you'll get a notification on your lock screen saying, hey, lock screen on the phone saying, hey, the Mac is trying to do an operation. And then you'll have the option to allow or deny and being able to go from there on that. So that's why we're using Bluetooth primarily. We are looking at using it as a fallback If for some reason multi-pair connectivity does not work, we'll then go to a Bluetooth connection to be able to make that operation happen. So again, you've got multiple avenues of making that happen, all transparent to the user. They just know that they click something on the Mac and then something happens on the phone. And that's really what we're going for here. For the iPhone setup, we're going to get into that a little bit later as to what we're going through here. But you deploy Jamf Connect from the App Store. The iOS app will be in the public App Store. You authenticate to a cloud identity provider. We're going to require that. So Okta, Azure, Ping, One Login, Google, whatever your fancy is. But we want to make sure that that user is very much the one that should be on that device. We will then use information from that cloud authentication, so the ID token that you get back from that. We will then create a certificate signing request. We will send that certificate signing request to a Microsoft NDES, Network Device Enrollment Service, SCEP server. All right. Microsoft is what we're supporting first. We're very interested in knowing what your environments may be and to know what else we need to support as we go forward with this. So for the user, they'll sign in to Okta, Azure, or whatever it is. They'll get that token, and then they'll immediately get a certificate from that token. And that certificate will then be matched to their account on the Mac, at which point they'll be able to use that certificate on the phone as a smart card to be able to sign into the Mac. We'll also gate all of this behind Face ID or Touch ID. We want to make sure, like I said, that the user on that device is exactly the user that is supposed to be on that device. So you will see Face ID, and if you have a Touch ID device instead, Touch ID, so that we're adding biometrics into this. Mac setup's pretty simple. Jamf Connect package deployed during enrollment, and then just scope a configuration profile as we go through there. Mike's going to show you some screenshots from this. We already talked about this in the keynote, but we do have an enrollment flow, although we're not, we wanted to make sure that we could support this, which would be an entirely passwordless setup on the Mac. But you don't have to do it that way. For a variety of reasons, you may want to use your existing enrollment process where a user would create a password for the local device. Especially with Intel systems and File Vault, there is no way to get away from that password. If you watched Apple's announcements at WWDC with forthcoming Apple hardware, the File Vault process has changed a little bit. You should be able to use smart cards with that. So we expect that passwordless to be able to unlock File Vault on Apple Silicon, at which point be really cool because we'd have that whole flow and you wouldn't have to have a password. However, we want to be very, very clear about this. As Mike already mentioned, you can very much have a password with your account. That way, if the phone is lost, if you need another way into that device, you can still use that password. What we're really looking at for this passwordless technology is to be convenient and make life easier for the user. The goal being that you can mandate a very long, hairy 128-character password that the user hates. They don't want to type it in because it's just so laborious to do it. But because
you have to write
it's so
that
long,
on multiple Post-it notes.
all across the screen, exactly. We should buy stock in Post-it notes. So you'd have a really long, hairy password, and the user would only have to know that in very few times, because most of the time they're just using their face on the phone to sign in. So we're looking at it as a convenience. However, in this enrollment flow and in general use of the device, if you want to have an entirely passwordless experience, we will fully support that. And so in the enrollment case, you would sign into your Mac through DEP, and in that customized enrollment would then be shown. You would use your cloud identity provider at that stage, authenticate with that, authenticate on the same cloud identity provider on the phone. That's what we use to match them up. And then we'll create an account on the Mac associated with that certificate, at which point the user can just punch in their PIN and away they go. If you watched the keynote earlier, you saw an example of this. Mike's going to break down the steps a little bit more when we get there. And then we're going to do some demos to give you a better idea of this. Since I mentioned it earlier, I wanted to even dive a little bit deeper onto this. All the communications we do between the Mac and the iPhone are encrypted by our process in addition to Bluetooth multi-peer connections being encrypted as well. So we didn't want to just trust what came in. We wanted to add an extra layer of authentication and encryption on top of that. And we've actually started using ephemeral keys. And we'll get into this a little bit. Depending on your time zone, maybe have a beverage while we talk about this, as it may help some of the understanding, because it can get a little bit hairy as we get into that. And you can, and we'll show you in the demos, you can require a PIN to be used. We're currently having a PIN on the phone that rotates every 30 seconds. So in addition to Face ID or some sort of biometrics for the phone to be used as your password, the user also has to type that same PIN in on the Mac. If the PIN is wrong, the authentication will fail. If the Face ID or the Touch ID is wrong, the authentication will fail. The PIN will be optional. So if you don't want to use the PIN, if you just want to look and go because you think, and this is a very valid opinion, that biometrics and the secure enclave and everything else on the phone is already enough, perfectly fine. You'll be able to not have that PIN at all. The user can just hit return and be able to move through those authentication dialog boxes. And that's when this really becomes almost magical, when you can keep your phone next to your Mac with the Jamf Connect app running, be able to do sudo, click on locks, other things, and authenticate just by kind of twisting your head a little bit and clearing that Face ID on the phone. It's a really nice experience. And that's exactly what we're driving for as we go through this. So when we're communicating with the phone, there is a certificate on the phone that's been generated during the initial setup process on the device. That certificate is known to the Mac because that's what we use to sign you in with. There's a pub key hash, a hash of the key of that certificate, then added as an authentication authority to the user record on the Mac. That's kind of the glue that holds us together. So whenever the Mac talks to the phone, we go through a bit of a process. The Mac generates a pair of ephemeral encryption keys. So this is kind of one-time use. Currently, they're RSA 2048 keys. We're adjusting as to how secure and if we want to ramp that up some. The Mac knows the public key of the phone because that's what we're using to identify the phone and glue it to the user. So the Mac will encrypt the payload. And in this case, the payload is going to be primarily 2, maybe 3 things. During an authentication operation at the login window, like you see here, the Mac generates a random blob of data and has the phone sign that data with its private key. By signing it, you prove that the private key is in your possession, you have access to it, you're able to use it. That signed blob comes back. The Mac validates the signature against the known public key or the certificate, and then allows or denies the action at that point in time. So 3 things in the payload. The first one is this random chunk of data that's going to be done, operated on by the phone. Second thing is the ephemeral key, so the public key that the Mac is using. That's going to encrypt the process on the way back. So keep that thought. And then the third piece is any sort of PIN. If the user has to enter a PIN on the Mac, that PIN is then included in this payload. These 3 things are then encrypted with the public key that exists on the phone, right? That's encrypted, then sent over multi-peer connectivity, which also encrypts, sent over Bluetooth, which also encrypts. Gets to the phone then uses the private key that it has. And this will be either directly out of the secure enclave if you're using ECC keys, or it'll be protected by the secure enclave, where we will use a key from the secure enclave to then encrypt whatever your RSA key or something else that you may be using is. So the phone gets this payload. This payload has been encrypted with the public key that the phone has that's known by the Mac. It has to use its private key that's only in the secure enclave or protected by the secure enclave to decrypt it. Once it decrypts it, I mean, to some degree, this is our first level of authentication, because if the phone doesn't have this private key, it can't even get to the operation itself. So the phone has to have the private key. The phone uses that private key to decrypt the payload, opens up the payload, looks at what it has to do, looks at what it has to sign, looks at the ephemeral key, looks at the PIN, all that stuff. First, it checks if the PIN's valid. If we're requiring a PIN, make sure the PIN matches what's being shown on that screen on the phone. If it doesn't, operation fails. It then signs the payload, signs that random bit of data using its private key. Again, that's in the secure enclave, protected by the secure enclave, can't be exported. So if you can sign it, it has to be that user on that phone. All right.
Is it specific to that device then as well?
Absolutely. It's a good question, and it very much is. When we're generating, this is why we go through the SCEP process. When we're generating this identity on the phone, we generate a private key, never leaves the phone. And if you're using ECC certs, it's the actual key in the secure enclave. So we have a very high confidence that it's locked to that device, and there's no way you can remove it from that device. Unless you compromise the secure enclave. And if you do that, you're not watching this session. You're living in your secret supervillain lair and
sounds
counting
nice.
Yeah, sounds nice. if you do it, Mike, let me know.
You're 3D printing your Bitcoin or something.
Exactly. So yes, unique key specific to that phone. And that's why, as we mentioned a little bit earlier, you can have multiple phones associated with the same account on the Mac. Each one has a unique key pair. And so you can associate those key pairs multiple times to the same user on the Mac. So you could have two phones and you could take your pick which one to use, those kinds of things. So once the phone is able to sign the random blob of data, it then takes the public key, the second piece of the payload, public key that was generated on the phone, and it encrypts the whole response with that public key. So the signed data, even though that's not sensitive, it's just a signature. Signature blocks are not sensitive blocks. We encrypt it. That way we know that even if anybody is listening, there's no way that they can get into it, no sort of malicious actor in the middle attacks or anything like that. So it's signed, encrypted, and then sent back to the Mac. The Mac then uses the private key, part of that ephemeral key set that it created before this connection happened, to decrypt the payload. That payload then includes the signed blob, and it sends that signed blob back up the stack to the Mac and says, hey, here's the response. Did this person successfully authenticate or not? So there's a lot of pieces that happen here. But again, this is all under the covers to the user. And we generate new keys every time we send anything to the phone. It seems like we're wasting keys. I always feel bad. We generate these keys.
Got to recycle those keys, yeah.
We don't recycle them. Exactly. We just throw them away. I mean, these bits that are never going to happen again. And there's, a finite, not very finite, but it is finite key space, with RSA keys, and we're just using them up. So every time we connect to the phone, we generate a brand new one. And that way, even if, we have perfect forward secrecy and some of these other things on it. So really good stuff that we're doing with this that allows for some great ways of securing these communications as we go through. All right.
Need some new key conservation technology.
Exactly. Eventually we'll run out. 2048 bits, it's a finite space. There's only so many keys that can be made. Anyway, with that, now we pull up a little bit. So we've gone hopefully really deep, maybe too deep. Now we're pulling back up a little bit. Mike's going to walk you through a little bit of what happened during the keynote at the login window. And then we're going to do some live, I'll use that in quotes. I'm really going to be controlling the machine. I don't know how we can prove that in this area or this era of remote.
You hold up the phone while you're manipulating it.
I could do that. Fair enough. All right. That's good. All right. So I'll show you that we're doing this live and that it's not just recorded, even though the whole thing is recorded, but this was actually done live while we were recording. All right. We've broken the fourth wall again. All right, Mike, take it away. Talk to us about the login window a little bit.
Let's give this a shot here. Perfect. So again, more so from the user's perspective of what's actually going to be happening when they try to interact with the passwordless system. We've got an iPhone on the left. We have our MacBook on the right. This is very similar again to the video that we had shown in the keynote previously, but this is all about the process of getting set up on the phone and creating a new account and signing into that account on your Mac. So we're presuming, again, you've got an iPhone. We've been able to push the Jamf Connect application to that device. It's a managed app. We have app config being pushed from the MDM. User goes to launch that application, and they're going to be presented with a sign-in for the identity provider for your organization. So if that's Azure, Okta, what have you, they've got that prompt through a web view to sign into that identity provider. Simultaneously on the Mac, you'll have also already gone through your enrollment process. So take the Mac out of the box, boot it up, go through your MDM enrollment. That lands your management profiles. And it's also going to push down the Jamf Connect application. So that's represented in this screenshot by our little widget that's above the username password field that you'd see in a typical macOS login screen. So this is not Jamf Connect's login window per se. This is the native macOS login window. But we have our widget kind of standing on top of it. And at this point, if you've booted up your Mac, gone through enrollment, you're typically required to go through enrollment by authenticating to your same identity provider during that process. And our widget is there waiting with a known user that's gone through that entire enrollment process. So we're at a waiting phase on the Mac. Phone is up. And we are waiting to sign into our identity provider. So once you are signed in on the phone, the user that has gone through that entire certificate enrollment process on the phone, that information is then communicated over to the Mac. And on the Mac, the individual has the opportunity to then create the appropriate user account in their name on the Mac itself. And when that account is then created, the phone will give you the necessary PIN that you'd want to have to use to then finally sign in to that account on the Mac. So there is no password creation, genesis in that entire process. It really is just that we have created a new account on the Mac based on the identity that came from the identity provider. And you're finally able to log into that user account simply by providing the PIN that is being displayed in the Connect app. And then you're into your account.
And if you look at the account on the Mac, you'll see an authentication authority. Currently, if you look at the account that you currently have, you'll probably see some sort of password hash or shadow hash reference in it. The accounts that we'd be creating here at this login window will not have that. They will just have a secure a token identity associated with it, which then maps it back to a smart card, or in our case, the Jamf Connect app on the phone. So otherwise looks, acts, walks, talks like a normal user account. It just doesn't actually have that password associated with it. And like we mentioned earlier, you can still use the existing login flow that you have today. If you want to use Jamf Connect with the Okta or Azure or Ping or whatever else to validate the user, perfectly fine. If you want to use Setup Assistant, perfectly fine. We'll have some options for you from just the Jamf Connect menu bar app that will allow you to then associate this phone with an existing user. So you'll be able to mix and match. And in the case of where you're not requiring the PIN, all the user has to do on the login field at the Mac is to just hit return, and they'll go right on through. There's a connected option here on that little widget. Clicking connected inserts and removes the phone virtually. So if for whatever reason you don't want to use your phone, instead you'd prefer to use your password, maybe the phone's not with you, or maybe you just want to make sure that you're using the password, you can actually disconnect or disassociate the phone with the Mac at that time. It doesn't break the pairing on the account. It's just saying, hey, the phone's not around, we're not going to use it. And then immediately that field will flip back to password. And I can show you that here in a little bit when we get into the demo. And with that, amazing live demo. All right, let's do this. Okay, so we've got a couple of things. So here's a phone, and I'm broadcasting, and if you can see, this will map up.
You got the same pin. I see it.
Got the same pin. All right, so this is the magician passing the hoop over the floating assistant. All right, so we've proven that there are no wires here. So we're now got this up. I'll be playing Mike for this little operation here. And Mike's got set up. We've got this pin showing. And important to note, if you've got PIN timing anxiety, you can hit the little refresh button and will automatically refresh the PIN and give you another 30 seconds. These pins are just randomly generated and rotated often. So the user never has to remember a pin. There's no pin to keep in mind. You just look at the phone and use it.
Do what the phone tells you to do.
Exactly.
Look at it, type this number in. Great.
All right, so the first place we like to start off with, we'll go to System Preferences here, and a nice simple thing that's got the lock here, which is Startup Disk. So we'll click this, you get the same dialog box here. Also keep in mind, if you do have Touch ID set up, this does not interfere with Touch ID. So if you are allowing your users to use Touch ID and you want them to use that for some things, no, Touch ID won't allow you to log in at the login window, just clear the screensaver. But you can actually use Touch ID here if you want. If you're preventing, or they haven't set up Touch ID, or they're not lucky enough to have a Mac with Touch ID, perfectly fine, because we'll be able to do all that. So instead, click Use PIN. You've got an option if you've got multiple users that are maybe set up with the same identity. Not to add more complexity to this, but the permutations are almost endless. You could have, if you're going with privilege separation and least privileged accounts, you could have a non-admin daily driver account and an admin account, both connect the same phone to the same identity, at which point you'd be able to pull down between them and then determine if you're going to sign in as an admin or not as you go through here. In this case, we're going to punch in this PIN, and I'm going to hit unlock. And if you look at what's on the left, you're going to see a Face ID operation, and then I've been authenticated, right? So no password was required, just putting in this PIN. And again, the PIN is optional. So if you don't want to have to use the PIN at all, you don't have to use it. That would be set through app config. All right, if I bring this back up and I click Use PIN, we also have, this will be part of the menu bar app, where you'll have the ability to, like I said, at the login window, unconnect the phone. So if I do that right now, you see that it immediately flips back to password. So if this account does have a password, they're able to use that password to then authenticate in. And if I just turn this back on, you can see it immediately goes over to PIN. If I type the wrong PIN in, it just immediately shakes me off. All right, so that way you know the PIN was incorrect. You don't even bother with the Face ID on the other side because the whole operation is going to fail. All right, so that's here. Other cool things, since there's a lot of folks out there that use this, here I am with a terminal window, and I want to be able to use this terminal window to maybe do sudo. So I can do sudo-s, and it'll ask me for the PIN on my phone. And if I do that and type this in, you get Face ID, and now I'm root on the device. So another cool way of using this is the ability to not have to use your password when you're doing something like sudo or something else.
Could you show that Face ID one more time for sudo?
I can, since it was covered up. Keynote had grabbed the cursor. All right, so let's try this again. There we go. And when you open up the app, if the app goes to sleep, you do have to Face ID biometric into the app, because again, this app is very sensitive, like a banking app or something else like that. So we wanted to make sure that we do that. So I'm not root anymore. I will do sudo-s again. Oh, I got to time it out. See, and now you really know it's a live demo, because we've had to do things that if we were recording it, we wouldn't have done. All right, so now I've got to enter the PIN again, and well, it just rotated on me, so I'll get the right one, hit return, you'll see Face ID, and now I'm root on the Mac again. So really cool, very simple way of doing it. And again, if you want to not use the PIN, but just Face ID, keep your phone next to your Mac on one of these little stands. All you have to do is kind of look, and you just gonna hit return, and away you go. It's a very cool way of doing this. So let me close out of here, whoops, and we'll show you one more thing. If you do have an installer, for example, because this can work in almost anything. So I just happen to have a Jamf Connect beta installer.
It's very meta.
Very meta. If you haven't been using our beta, we've got a beta of 2.0, and 2.0 is shipping very soon. So now we've broken the fourth wall again, because by the time they listen to this, 2.0 will probably be shipping. not the passwordless part. That comes a little bit later. So you won't have a beta. Anywho, go to install. It's going to ask you, can use PIN here as well. So pretty much anywhere where you can use a password, you can use this. And again, if you're not requiring the PIN, you'll just be able to hit return and then look at your phone, do Face ID, and go from there. So it does make for a very pleasurable way of using the phone and the device for there. So that was our amazing live demo. Integration of passwordless, we just did a couple of screenshots here so you kind of marvel at your own speed on some of these. Again, you just hit use PIN. The PIN prompt will show up. You'll be able to type in the PIN if you're requiring it. Otherwise, just hit return. Same thing for authentication to sudo, and also then for installation. And at the login window, this is kind of zoomed in to what we showed you at the keynote, you will just get a small PIN prompt there. And so you'll have the option to just type in your PIN. Other cool thing about the login window is that you don't even have to pick your user, because as soon as it sees a card, or in our case, the Jamf Connect app has been inserted, it will flip to that user. Since most of your Macs are probably single user systems, this way the user will always be front and center. All they have to do is hit the PIN, or again, if you're not using the PIN, just hit return, and you'll be able to authenticate into the Mac without having to do anything else.
And that's not just for a login window. That's also for screensaver, wake from sleep, lock screen places.
Correct. Absolutely. So looks very similar, right? Mm-hmm. But yes, login window, any wake from sleep, screensaver, any of that, very similar operation. Type the PIN and go. And as File Vault progresses on the Apple Silicon, it should do the whole File Vault and everything else there as well. So we're very excited about that for a really nice, smooth way. And again, there's no reason why you couldn't use an account without a password, especially with File Vault being addressed in future versions. However, you don't have to do it that way. We expect most people will use this as just an add-on to their existing flow to make life easier for the user.
A little shortcut, a little convenience.
Yeah. Little shortcut, little convenience, and not necessarily a major change to their existing flow. And with that, I'm going to hand it back to Mike, and he's going to walk through deploying it real quick.
Certainly. So I think, as Joel has kind of demonstrated here, there's two main components to this entire workflow, right? Between the Mac and an iPhone, we need to have a fully managed Mac so that we can push down our Jamf Connect packages, or package, I guess. That's going to be done either through your pre-staged enrollment or a policy post enrollment if these are Macs that maybe are already in use and you want to be able to adopt these passwordless workflows. And on the iOS side, of course, we have our Jamf Connect app as well. So that also needs to be on a fully managed device. If you've got Apple Business Manager set up and that's all connected to Jamf Pro or your MDM to distribute the application, the key component is having app config. So we want to be able to get the application to communicate to the right identity provider, and that's only going to happen on a managed device. The Connect application itself, that's all going to be part of 2.0, is going to include all of the necessary bits to drive this passwordless workflow. So it's going to be built into the existing applications that we use to support identity providers today. And again, as Joel mentioned, with the app itself, it's going to be hosted in the public app store, so we can use Apple Business Manager to get tokens for the application and then push it down as a part of an enrollment process or just simply scope to your devices. And how that app functions will all be managed via app config. One wonderful thing, I think, about being able to manage this all via MDM, and we haven't talked about it too much, in addition to enabling, is the kind of disabling aspect, right? If I want to remove or prevent access to this application, being able to have MDM commands to either revoke an application or using different management commands like locking a device, like locking somebody's iPhone, prevents you from necessarily being able to use that application to then unlock your Mac. So there's some neat new workflows that can be enabled as a result of kind of bringing these different systems together and coupling it with MDM.
Absolutely. I mean, our mind is reeling about some of the really cool things that can be done when you get into this environment, because you do have effectively a password that you can control through MDM. And you'll see some really cool things, I think, following up to this as we, refine this process and release more versions that will make it even nicer. And just before we close out, we are very much interested in feedback. We do hope to have a beta version of this out relatively soonish, so that you can start playing around with it, because we do understand that this is going to be a relatively significant workflow change.
It's a new process for a lot of people.
It's a new process for a lot of people, exactly. And so we do want to make sure that users and admins feel comfortable with it. And we hope we're kind of hitting this Venn diagram of making things more secure, which everybody's excited about, except maybe end users, but yet making it also easier to use. And hopefully we've got that little piece in the middle that we've been able to increase security on the device, but then also increase the user experience. And that's, the really nirvana that we're looking for. Thanks for joining. Great to have everybody at JNUC. And, again, we're really excited to be talking about this and showing what we'll be doing in a little while.
Yeah, look forward to talking more about it and hearing back from everyone.
Thank you. Have a good afternoon, evening, wherever it might be for you. And
thank you. And thanks, Joel.
Thank you, Mike. Definitely. No, it's been a pleasure. And we'll chat with you next JNUC. See ya.